Here is my circuit. I have the thermocouple with the thermocouple amplifier here. It's being powered by the 3.3 volt rail connected to the ground. Then I have these 3 wires going to the nucleo, the chip select, the DO, and the clock. And so to run this experiment, I first put this in the hot water to heat it up, and then once it reaches a high enough temperature, move to the cold water. And so we can see a demonstration of that here. So right now, here's the putty, nothing's on it. Once I click this blue button, it'll start collecting data. So there's just room temperature right there. And so I'll drop it into here and start the data collection. So we can see the temperature rapidly increasing in the hot water. And I'll go ahead and stop that there. In the real experiment, I let it heat up a lot more. But I'll move it to the cold water, start the timer, and we can see the temperature dropping. And so I'll go ahead and stop that. So to calculate H value, I imported this data into Excel, and I was able to use the lumped capacitance method, where I took the initial temperature, the temperature of this cold water, which I measured using a thermometer, and then other characteristics of the ball, the density, surface area, volume, the specific heat, and using the lumped capacitance equation, able to use that to calculate H based on the time that the ball spent decreasing temperature from the hot to the cold.